This is part 2 of our look at the ambiguous case of the sine law. I'm splitting this up into 2 videos because the first one was getting a little long. So in the first video we discussed the basics of the ambiguous case and the fact that to be the ambiguous case you needed to be given 2 sides and an angle that wasn't between those 2 sides. So a non-included angle is the proper vocabulary there. And when you have that situation and you use law of sines, there are 3 possibilities that result. Either in case 1, we had a side that was just long enough to reach. Example 2, or case 2, we had a situation where the side wasn't long enough to reach at all, and we had to say that the triangle could not exist as specified. And now with example 3, we're going to have the situation where we have a side that is long enough to reach in either of 2 places. So there will be 2 possible triangles. So I want to discuss why does sine produce that? Why is that possible? So let me sketch a coordinate plane here and let's explain it. So let's say, for example, that I have a terminal side here in quadrant 1 and I tell you that this angle is 70 degrees, for example. And then we have a terminal side over here in quadrant 2 that has a reference angle of 70 degrees. So in other words, this angle and this angle are the same, they're congruent. So that would mean that the full angle, so in the full measurement here, would be 180 minus 70 for this angle, so 110 degrees. So what I am going to show you is that sine of 70 is going to be exactly the same as sine of 110. So I'll prove it to you. Sine of 70 is that decimal. Sine of 110 is the exact same decimal. So what does that mean? That means that if you are using the law of sines and you have the ambiguous case set up and you get an angle that is between 0 and 90, an acute angle, that means there's another possibility for it, that it is the 180 minus that angle, because you're producing a sine value. Let's say you had 0.93969, etc. Well, that could mean that your angle is 70 degrees or that your angle is 180 minus that, or 110, because the reference angles are the same. And you notice that they're both one's in quadrant 1, one's in quadrant 2, where sine is positive. So the sine values can be the same. There are 2 places in throughout the 360 degrees here where the sine values are equivalent, and that's when your reference angles are exactly the same. Okay, so that is why it happens. Now let's look at this specific case. I'm going to erase this and we'll look at it here. Alright, now for this specific case. So let's draw our ABC triangle here. So we're using A, B, and C like this. And now let's fill in the given information. Side B is 20. Side C is 13. Angle C is 30. So we have the ambiguous case for the sine law because we have 2 given sides and an angle that's not between those 2 sides. It's a non-included angle. So this is setting us up to have the ambiguous case. So let's go to work and figure this out. So we have a complete sine pair here, the angle and the side. So that one we'll be using. Sine of 30 degrees over 13 is equal to sine of angle B over 20. So we're finding this angle right here. So we do that work and we get sine of angle B is equal to 20 sine 30 all over 13. If you cross multiply and divide, you'll get to this point. So that means that angle B is equal to the inverse sine of this 20 sine 30 all over 13. So let's do that work here in the calculator. Sine inverse of this quantity, 20 sine 30 all over 13. So we get 50.28 degrees. So in this case, our angle B is 50.28 degrees. But we have this problem. If you have the ambiguous case and your angle that you get from your work is between 0 and 90 degrees, it's an acute angle, then that means you have 2 possible solutions. It's either 50.28 or it's 180 minus that. So 180 minus Second answer here is 129.71. We'll round to 0.72. So I have to solve this triangle twice. Once with angle B being 50.28 and once with angle B being 129.72. And that's because of the picture that I drew you earlier. So in other words, sine of 50.28 is going to be the same as sine of 129.72. Now there is some rounding error, but you're going to see they're very, very close. So sine of 50.28 gives us that decimal, and sine of 129.72 is going to be very close. We have rounding error, so it's not exact, but you can see they're, as far as the calculator decimal places go, they are exact. There would be a little rounding error there. So there are two possibilities here. Either angle B is 50.28 or angle B is 129.72. So I'm going to copy this triangle down because we will be using that again in a moment. And I'm going to make it 129.72 in this case. So let's make it 129.72 here. So we'll solve that again here in just a moment. Okay, back to our first triangle that we have to solve. So angle B in this case is 50.28 degrees. So that means angle A is 180 minus 50.28 minus 30. Whoops. Minus 30 and 99.72. So we have all three angles. We have two of the sides. Now we need to finish the problem by finding this side length over here. So we'll use this sine pair that we were using before. Sine of 30 over 13 is going to be equal to sine of 99.72 degrees, all divided by this missing side, side A. So we cross multiply and we'll end with this. Side A is equal to 13 sine of 99.72 degrees all over sine of 30 degrees. So let's do that work here in our calculator quickly, and we get 13 sine 99.72 all over sine of 30. That means side length A is 25.63. So this is one possibility. This is solving this triangle. This is possibility one. The other possibility will be with the angle B being 180 minus that 50.28. So let's do that one next. Quickly, I want to fix this picture for you so it doesn't confuse you. So in this case, this is the way that the triangle would look. If this side, let's move this over here. If angle A in this case is 99.72 and this one is only 50.28, that means the triangle looks more like this in this case. So this is our 50.28 angle up here, 50.28, and this is our 99.72 angle is down here. So the picture, the triangle it would produce would look more like this than the way we originally drew it when we didn't know exactly what it looked like. So that is more to scale on how this triangle would look. And if you notice, the 99-degree angle is pointing to the biggest side, 25.63. The 30-degree side is pointing, that's the smallest angle in this case. It's pointing at the smallest side. And the 50.28 angle is the medium angle, so it's pointing at the medium side length. All right, let's look at that next example where we have the other case of the angle being 129.72. All right, so here's our second scenario, and the picture just happens to work out where this one looks fairly accurate. So we need to find angle A here. Angle A would be 180 minus 30 minus 129.72, and it would be 20.28. And so we have all three angles now, so now we just need to find the sides. So I use my sine ratio that I have complete. Sine 30 over 13 is equal to, we're missing side A here, so I'm going to use sine of angle A, 20.28 degrees, all divided by side A. So if you cross multiply and divide, you'll get A is equal to 13 sine of 20.28, all divided by sine of 30. So let's put that in our calculator and finish this problem. So 13 sine 20.28 all over sine of 30. And we get a side length of 9.01. So there is the second possibility for the triangle. And you'll notice the 30-degree angle is the medium angle, so it's pointing at the medium side length. The 20-degree angle is smallest, so it's pointing at the smallest side. The 129-degree angle is the largest angle, so it's facing the largest side. So that is it for the ambiguous case of the law of sine. So let's just recap quickly. 3 possibilities when you have the ambiguous case. The ambiguous case occurs when you're given 2 sides and an angle that's not included. In other words, an angle that's not between them. And your 3 possibilities are the side length is perfectly reaches, so your angle, you have a 90-degree angle in your triangle. The second possibility is that the triangle is impossible and the side will not fit at all, and you'll get an error when you're doing your work if you're using your calculator there in that scenario. And the third case is you get an acute angle when you're working through your trig work, and you have to solve for 2 possibilities. One is the angle you're given by your calculator, because your calculator is only going to give you the acute version, the one that's between 0 and 90. And you also have to solve 180 minus whatever that angle is, and we discussed why that is allowed to occur, why that is possible. So that's it for this video. You have part 1 with case 1 and 2, case 1 being the 90-degree angle situation, case 2 was the impossible triangle, and then this video was all about case 3 where we have 2 possibilities. Alright, that's it for this video.